Thank you very much again. I'm going to give, I think the timer here, it's still, are you able to re-zero the timer? That's fine.
Yeah, I'll do it.
Yeah.
Oh.
Is it?
You got it.
Oh, it's there. So again, I have a few disclosures related in this field that I presented before. I also would like to mention there are several commercial devices available in the market for ex vivo lung perfusion, and all the data I'm presenting here, it's not related to any of those devices. As you know, we have this method which is described as the Toronto method of EVLP. Again, consists of a tubing circuit which is provided by Mackay, and then we have the ex vivo dome provided by ex vivo with the cannulas and an ICU ventilator and the tank of gas. And this is the timeline of development of EVLP in our center. We started in end of 2005 with some animal studies and equipment troubleshooting. And after our initial publications, we designed this human trial. In 2008, we did our first patient here. And we completed the clinical trial in 2010. And this was approved for clinical use in Canada in 2012. And then 2012 was reimbursed. And now it's a fully reimbursed activity by the Minister of Health in Canada. We published our initial results in 2011. And again, just to show, safety of this method with no differences in PGD and similar survival over 133 patients. One of the interesting findings in this study was that indeed we have less PGD 2 and 3 in the EVLP arm. This was a matched cohort compared to the conventional transplants. And so that was an interesting finding. So in terms of our experience to date at Toronto General Hospital, we have done 397 clinical EVLPs, and 55% of those were for high-risk DCDs, high-risk brain death donors, 11% for the standard DCD. I mean here standard DCD is the DCD that has no apparent issues, has a quick arrest, and you could theoretically go ahead and transplant directly, and many centers still do that. And 29% for a high-risk DCD, which is the one that takes more than 60 minutes to arrest or have other concerning findings. And then the logistics or retrieval by another team. And this here showed the number of EVLP cases by year, and you can see here that has been a steady increase in the number of EVLP procedures. And on this graph here, we have the use rate after EVLP, which you can see here. It's variable depending on the year, but it ranges in about 65 to 70% of use more recently. After a lung go on EVLP. In the yellow bars here show what is the percentage of our transplants that are from an EVLP lung. And again, it's in a range of 30% of our transplant activities are from that. And it did have a significant impact in our increase in activities, with about 70% increase in lung transplant procedures over the EVLP era when we started around here. I think it's very important to show that despite having a very significant growth using these extended criteria organs, the 30-day mortality continues to be low, with an average 3% 30-day mortality over the more recent years. So I would like to comment in a bit more detail about the role of EVLP in our Center for DCDs, and then the role in extending lung preservation, and then finally talk a little bit about the implementation process. And so when we look at DCD, data in the United States show that the use rate is very low. And you know, previously I've showed you a slide from 2010 that the use rate for DCD was 2%. This is from 2016 paper, again looking over the last few years, again very low compared to NDD utilization in the range of 21%, or the DCD use in Canada, Australia, and Europe, almost 30%. So I do think EVLP can have a major role in improving DCD use rate in the United States. Here is to show that most centers which are experts in DCD lung transplantation, they do use EVLP. This is a bit of an old table from 2015. I think some of the centers that said no at that time now are starting to use. For example, Melbourne, they just did their first EVLP case, and they seem to be pretty happy with that. And so it's coming up. And I think one of the questions is whether all DCD lungs should be treated with EVLP, and that's one of the more controversial aspects here. And even in our center, we tended to use EVLP selectively in DCDs and not for all of them. But we did have a few surprises when we went straight ahead. And so this is a very typical case from last year. This donor took 3 minutes to arrest. The lungs were perfect before. The PO2 was 500, X-ray was clear. The bronchoscopy after withdrawal was fine. And the lungs are very light after flush, no problems. And the patient go to a straightforward transplant and get a very severe PGD requiring ECMO post-transplantation. So this is the type of thing that we are pretty sure we can avoid with EVLP, because we have seen the same scenario of good lungs that we put from DCDs that we put on EVLP, and they do develop massive pulmonary edema just in a few minutes after being perfused. So I think this is really an unrecognized injury that happens during the process. In our institution, when we compare the outcomes of DCDs that underwent EVLP versus no EVLP, we could see that all patients that received DCD EVLP lungs, they did better with 3 days less of ICU stay and 5 days less of hospital stay compared to the DCDs that went straight for transplant. So I'd like to talk a bit about extending lung preservation. We have shown in an experimental model that we can, combining cold preservation with EVLP, you can extend a lot your preservation time. It's like EVLP really reset your clock from the preservation. And we have here 26 hours of preservation being 10 cold ischemic time versus more 6 EVLP, and then 10 cold ischemic time 2, and perfect lung function after transplantation. So this was the experimental model which led to this clinical study, which again, it did show over 100 patients we transplanted with more than 12 hours of preservation, and a lot of them in between 14 to 18 hours of preservation. And they had exactly the same outcomes that patients that had significantly less preservation time. So in terms of our practice, we routinely transplant lungs over 12 hours of preservation time. One of the important features is that patients can remain at home. This is especially important in DCDs, as about 40 to 50% of the DCDs don't arrest. So it's very disappointing that we were calling all these patients to hospital because there was a donor for them, and the DCD don't arrest and they were sent home. And this was happening very often. And so now we only call the patient to the hospital once the donor arrests. The team flush the lung, look how the lungs look like, and if they are okay to go to EVLP, then the patient is called into the hospital. We also think there is no need to rush in difficult cases, worrying about ischemic time. I think this is quite important. And more importantly as well, we think more transplants can occur in the daytime, and we're actually planning to start a preemptive study of moving night transplantation to morning transplantation by putting the lungs on EVLP overnight. This is just a communication I had with the surgeons that was involved in the LB clinical trial. And this is the surgeon from another center saying, "Great lung, thanks for your help." And I just say, "Glad to hear." And I say, "Even better, you could start your transplant at 7 o'clock in the morning." And he texted me back, "I agree with my day team and best anesthesia. makes all the difference. So I think there are, and people realize there are main advantages of doing transplant during routine hours compared to starting at 2 o'clock in the morning, even from patient safety perspective, not only from staff perspective. And I just would like to finalize implementation process. As you know, there are two models. The transplant-centric model, which each hospital had have their own perfusion apparatus, and there's the organ repair model. And again, this will be discussed further in this session, where this is a centralized organ perfusion center that distributes. And I think in Toronto, we have a bit of a mix of both. Basically, for donor offers in Canada, we send the lungs to our own organ repair center and then direct it to transplant TGH. If there are donor offers in the US, if there is logistics possible to send the lungs to us, we'll do that. But if not, the lungs are directed to the lung bioengineering and then redirected to us after that. In terms of the early days of EVLP at TGH, you can see here Shaf. That's probably one of the few times he took a picture doing an EVLP. I think it was the only case he was in the EVLP OR, and he took a picture 2008. But just to show the evolution that the expert team was there for the beginning of the experience, and as we moved on, we saw this is really not feasible from the practical standpoint, and so we moved on to fellows. Dr. Mashuka is here, was our fellow there, and he carried the EVLP activities for a couple of years as well, very successfully. And he was quite well trained on that in the lab. And now we moved on to the organ perfusion specialists. And we basically have 3 EVLT teams in our hospital, and they are in pairs, which include 1 full-time organ perfusion specialist and 1 research fellow, which pair with them. And this is someone that is doing lab EVLP projects. So these are the 3 full-time organ perfusion specialists, which are paid by the hospital, but they also work part-time in the lab. And they do have to have training in many of these disciplines to get certification for this. And this is just an example of the call schedule. We have a first and second call because oftentimes we'll have 1 or 2 EVLPs coming up at the same time, and so we may need more people. And you can see here, this is the fellow that pair with them to help with the procedure. And this is just to finalize. This is how we get the report as a staff surgeon. So at 3 o'clock in the morning, I'm sleeping in my bed, and the message was already sent to them, just call me at 4 hours EVLP, and then I'll look at the numbers. And so they called me at 4 hours. I just look at my iPhone here, and that's the picture I get here. And so I have an X-ray, have all the numbers. I see how the lungs look like. I see the video of the deflation test. That is quite well documented. And at that moment, I just say, okay, ask the nurses to bring the patient, to the room in the next hour or 2, and then I wake up at 6 and go to the hospital to do the transplant. So that's how things are working. In conclusions, 30 to 40% of our lung transplant activities come from EVLP lungs. EVLP is a very effective method to test quality and improve function of DCDs and NDDs. And combining cold preservation and EVLP allow us to bring lung transplantation to a more semi-elective procedure with several advantages. Thank you very much.